Overfitting happens when a machine learning model memorizes its training data instead of finding the underlying patterns. While it might perform perfectly on the data it has already seen, it fails to generalize to the real world. In production, an overfit model will be confidently wrong whenever it encounters new inputs that differ even slightly from its training set. You can spot overfitting by tracking training loss and validation loss together. If the training loss keeps dropping while the validation loss plateaus or starts to rise, your model is overfitting. This usually happens when a model has too many parameters relative to the size of the data set, when the training data lacks variety, or when you train for too many cycles. To prevent this, you can use several strategies. The first line of defense is early stopping, which means monitoring the validation performance and stopping the training process the moment it stops improving. You can also use checkpointing to save your work along the way, allowing you to easily roll back to the model's best state before it began to overfit. Other effective techniques include dropout, which temporarily disables random neurons to force the model to learn broader representations, and weight decay, which penalizes overly complex decisions. Finally, you can use data augmentation to create variations of your existing data. Ultimately, the most reliable cure for overfitting is simply gathering more diverse data, which naturally forces the model to generalize rather than memorize.